right, we're going to simplify radicals here. Made a little table of perfect squares. We're going to use the numbers that are down in this right-hand column here. Okay, they're the perfect squares. The square root of 4 is 2. Square root of 9 is 3, etc. Don't use 1 because 1 goes into everything. And also it goes past 100, goes on forever. So sometimes you can use numbers bigger than that. So we want to find the biggest number in this perfect square column that goes into 20. So the biggest number that goes into 20 is 4, which is a perfect square, and it goes into it 5 times. And then we take the square root of 4, which is 2, square root of 5, we can't do anything with, so our final answer is 2 root 5. So you can pause the video and try to do some of these other ones on this top row and see how you make out. All right, let's see. So the square root of 48, the biggest perfect square that goes into this, try a couple of them, you might have to go higher, would be 16. So the square root of 48 is the square root of 16 times the square root of 3. Take the square root of 16, which is 4. Square root of 3 we leave alone. Final answer, 4 root 3. Square root of 50, biggest perfect square that goes into that, it's 25. 2 times. Square root of 25 is 5. Square root of 2 comes down. Final answer, 5 root 2. Biggest perfect square that goes in 18 is 9 times the square root of 2. Square root of 9 is 3 root 2. Okay, so then we're going to come down here. Square root of 17, there is no perfect square that goes into 17, so that is the final answer. That's done at that point. Now, this is written 3 times because I want to show you a couple different ways to do this. The best thing to do, the fastest thing to do, is get the biggest perfect square that goes into 128. So you have to try some numbers, and you try bigger numbers till you get the biggest. That's going to be the square root of 64 2 times. Square root of 64 is 8. Square root of 2 we leave alone. Final answer, 8 square root of 2. So if you did some delta math problems, you would have seen some multiple step ones. So the square root of 128, let's say you used a 4, okay, and you figured out 32 times. All right, well, square root of 4 is 2 root 32. But root 32 can get broken down. There is a perfect square in there, which is 16 times 2. Square root of 16 is 4, so this comes down as a 2. 16 is 4, square root of 2. 2 times 4 is 8. 8 root 2, same answer we had right there. Okay? Somebody else might do it like the square root of 4 times the square root of 32. 2 root 32. But then they might say if 4 goes into that, square root of 4, 8 times. And they say 2 times the square root of 4, which is 2. And then they have the square root of 8. But square root of 8 can be the square root of 4 times 2. So it's 2 times 2 times the square root of 4, which is another 2 root 2. 2 times 2 times 2 is 8 root 2. So see how this one was much longer? Because you didn't get the biggest perfect square in the very beginning. Okay? All right, so now how do we go backwards here? Well, 2 root 3 squared. All right, I'm going to do the first one, then you're going to pause the video and do the next 3. 2 root 3 squared is 2 root 3 times 2 root 3. The numbers outside, we regroup them, put them together. The numbers are inside the radicals, put them together. Okay, multiply these numbers. 2 times 2 is 4. Root 3 times root 3 is root 9, which is a perfect square, which is 3. So that becomes 4 times 3, which is 12. All right, pause the video and try these guys. All right, so this is 5 root 7 times 5 root 7. 5 times 5 times root 7 times root 7. 5 times 5 is 25. Root 7 times root 7 is root 49. Perfect square. Square root of 49 is 7. 25 times 7 is 175. This is just square root of 6 times the square root of 6. 6 times 6 is 36. Underneath the radical symbol, square root of 36 is 6. What did you get for this one? 4 root 5 times 4 root 5. Group them together. Okay, I wouldn't skip steps. Just keep doing the same thing. 16 root 25. Square root of 25 is 5. 16 times 5 is 80. That's all you need for breaking down radicals and squaring them. All right, now let's move on to some ratios, all right? Reduce ratios. Let's see, this is supposed to be ratios. It looks like a 5. So to reduce ratios, what we need to do is reduce the fraction, if you can. So you have to know what goes into 18 that also goes into 14. The biggest number, that's going to be a 2. So you divide the top by 2, divide the bottom by 2. That becomes 9 over 7. What's the biggest number that goes into 25 that also goes into 15? 5. So we divide this by 5. Reducing ratios, you're getting equivalent fractions. 25 divided by 5 is 5. 15 divided by 5 is 3. Now, when you have units on there, you got to change them to the same term. So 3 weeks, 9 days. All right. I think that was, yeah, sorry. So there's 7 days in 1 week. Okay, so in 3 weeks, there's 21 days. The bottom stays the same, 9 days. Okay, and now you're going to cross off days and you're going to reduce 21 over 9 the same way we did over here. Biggest number is 3 that goes into both, so that's going to be 7 over 3. So this is 30 seconds, 4 minutes. There's 60 seconds equals 1 minute. You always want to take the bigger unit and make it smaller. 30 seconds. 4 minutes is, 240 seconds. Okay, and then we cross this off. See, we kept the top the same, bottom changed. Over here, the top changed, bottom stayed the same. There's no set rule. And then you reduce this fraction. This is going to be 1 over 8. Okay, solving a proportion. When you have two ratios, you cross products. 3 times x equals 2 times 9. 3x equals 18. Divide both sides by 3x is equal to 6. We'll try it again over here. You can multiply these numbers first if you want. And then these ones go on the right-hand side. 4 times 12 is 48 equals 16x. Divide both sides by 16, x is equal to 3. If I took the 3 and I put it back over there, that would be 4 over 3, 16 over 12. Reduce this ratio, same way we did up above. That's 4 over 3 equals 4 over 3. That's how we know we're correct. So I hope this helped.